Have you ever wondered about the efficiency of your code? It can be a real puzzle, especially when it comes to understanding performance. If you're curious about the big O notation of the bitCount method in Java, you're in the right place. Today, we're diving into this topic and breaking it down for you. I totally get it. Trying to figure out the performance of a method can be confusing, especially when you're not sure how it works. You're not alone in this. Many developers have the same question about bitCount. Here's the specific question we're addressing today. One user asked, "What is the big O of bitCount?" They assumed it might be O of log n. Let's take a closer look at this method and see if that assumption holds true. To understand the big O of the bitCount method, we first need to know what it does. The bitCount method counts the number of 1 bits in the binary representation of an integer. This means it processes each bit of the integer to determine how many are set to 1. And stick around. At the end of this video, I'll share a quick tip on how to optimize your code for better performance. To understand the big O notation of the bitCount method, we first need to clarify what the method does. The user should know that bitCount counts the number of 1 bits in the binary representation of an integer. Next, let's analyze the operation performed in the code. The user is using the bitwise XOR operator, which compares the bits of 2 integers. In this case, the integers are 4 and 1. Now, the user should consider how the bitCount method processes the result of the XOR operation. The method iterates through each bit of the integer to count the number of 1 bits. Finally, the user can conclude that the time complexity of the bitCount method is O log n, where n is the value of the integer. This is because the number of bits in an integer is proportional to the logarithm of its value. Fun fact, the largest integer you can represent in Java is 2,147,483,647. That's a lot of bits to count. Now let's look at the answers provided by other users. An alternative approach provided by a user states that the big O of the bitCount method is O of 1. They explain that this method uses a series of bitwise operations to count the number of 1 bits in an integer efficiently. That's all for that response. Let's see what someone else had to say. This user provides an alternative perspective on the big O complexity of the bitCount method. They explain that any algorithm operating on input of limited size has a complexity of O1. Since bitCount works with a fixed size input, they conclude that its complexity is O1. Here's the tip I promised. When optimizing your code, always consider the data types you're using. Choosing the right type can significantly impact performance. And there you have it. The big O of the bitCount method is O of 1. Understanding these concepts can really help you write more efficient code. If you found this video helpful, please subscribe for more insights, and don't forget to check out our next video on optimizing Java performance.